Hi, good afternoon. This is just to introduce the lab, which is diffraction and interference. We will not do any calculations in this, I would say lab, but every time you are going to, make a change, you're going to take a screenshot. And then your lab is going to be a formal lab report that you are going to include all the screenshots, but just please label them based on what is really the wavelength and what is really the slat, spacing. Okay, today we will study diffraction and interference. In the first part, we are going to study diffraction, where we are going to make, the slit width very small compared to, it's just like we're gonna have it small so that we will not be able to have just the diffraction without having more interference. And diffraction is bending of light when it's moving through an obstacle or apertures or any opening. Okay, then we are going to see that the light is going to behave in a way to show the pattern that we are going to see here. And of course, we are going to use Beyond Lab Z. You will log into your account, and then you are going to use, from the desktop, you are going to go to virtual physics, and then from the list, you are going to find the experiment, which is called diffraction and interference. All right, now let me show you here how we are going to do the experiment. The first part here, it said start virtual physics and select diffraction and interference from the list of assignments. The lab will open in quantum laboratory. A laser is used as the light source. Of course, it's monochromatic. It has only one single wavelength. We will not see diffraction patterns from other wavelengths interfering in the image. Now, this is the laser here, and this is the wavelength of the laser beam. Here, this is the slit, and this is the spacing of the slit. There is a device in the middle where we have that, like this is the, and then we will be able to view what you can see on the screen here. Okay, first observe the current pattern and predict how the diffraction pattern will change as the wavelength changes in question 3. Then this is one of the questions that you are going to answer. You're going to predict, like it's just what is your thinking about this, and then you are going to start changing the wavelength from 700 to 300 and keeping the slit at the same spacing. Then I will say here I'm gonna have this 700, and then I have it recorded here. Then I will just take a screenshot of that, and that is gonna be for 700 nanometers, and it is the 0.2 micrometers. Okay, and then I will move to, like, I can barely see it. Okay, okay, now I can reduce the wavelength to 600, and then again take the screenshot, change it into 500 and take the screenshot. Of course, you know that the frequency of the light, which is the color, which is related to the wavelength, has to do with the color. Okay, and then we need to go to 300. Okay, then every time you are going to screenshot, and then you are going to record your observations in question number 4. This is, you're gonna call it task 1. Now for task 2, we will investigate other interior interference effects And once we spread out the slits further, we can start see interference when waves passing through the two different slits. Now we are going to change the wavelength into 500, going back to 500, and then we are going to have this as 0.3, no, 3 nanometers. Micrometers. Okay, then now we are able to see the effects of interference. All right, then now you will investigate the interference effects. Once we spread out the slits further, we can start to see interference, and this is for the 500, which is the green color. Change the wave and the slit to record your observation in question 5. Okay, every time you are going to make changes, you are going to take screenshots again and insert this under like task 2. Now we are going to change the slit difference, the slit spacing into 1. Okay, then I'm gonna reduce this to 1, and we're gonna look at the fringes and find out, you know, what is really the pattern displayed, so that when you are going to change the width slits from 1 to 7, then this is number 1, and then you're gonna keep the lambda constant, and then you're gonna go to 2, and then to 3 and 4 and 5 till you reach 7 micrometers. And every time you are going to have you're going to have a screenshot, and this is going to be task number 2. Now, task number 3, we are going to return to slit 3. Okay, then we are going to make that 3 micrometers, and then increase the wavelength of the laser to 700. Okay, and record your observation on how an increase in wavelength changes the interference pattern in question number 7. Then here, what we are going to do is we are going to find out how really the wavelength is gonna affect. Then we did this for the first one we did for 500, and now we did for 700, and I will say we are going to compare the two and find out, because we did the 3 under it was which one, number 6, and then you're gonna compare 6 with 8. Now we are going to change the intensity of the laser from 1 nanometer to 1 nanowatt to 1 watt. Then here I'm gonna make that, increase that to 1 watt. This is 1 watt. Observe the diffraction pattern and record your observation in you know, like you're gonna answer it, okay, under the questions. Decrease the intensity of the laser to 1000 photons per second. This is 1 photons per second, and here you're gonna wait. Click on persist button on the video camera to look at individual photons coming, and that one is the persist. Like you can see it. I don't know if you will able to see it. I can see, you know, these photons. Observe for 1 minute, and you're gonna take a screenshot. Okay, and then decrease the intensity to 100 photons, and then again you are going to observe for another minute. And at these lower intensities, there is another time when 2 photons go through both slits at the same time, and therefore we are going to have the buttons that we have in here. The last one, you're gonna call it task number 4. Again, every time you are going to have your screenshots, you are going to answer the questions about your comments for all the parts that we were asking about. This should be like a very easy lab. I don't expect like any any difficulties. Anyway, you can communicate with me anytime about this lab. Thank you very much and have a great day.